This is a really, really important and really useful concept that you will use forever and ever in mathematics. And it just is about a really special quality about a right-angled triangle or a right triangle that says that the two shorter sides, when you square them and add them together, they will equal to the longest side, but it's got to be when it's squared. So we got to know first a few words. The hypotenuse, what a crazy word, is the longest side, and it's the one that is opposite the right triangle. The square of the length of the hypotenuse, which is to say c squared, is the sum of, or is equal to, the sum of, so I'm going to put a plus in there, the squares of the two shorter sides. So it doesn't matter if it's a squared plus b squared or b squared plus a squared. It doesn't matter. It doesn't matter which one of these we call a and which one we call b. As long as we square them and add them together, they will equal c squared. Pythagorean triple or triad is a set of whole numbers that, when you do that process, you square the two shorter sides and add them together, and they equal the longer side squared, then you've got a Pythagorean triple. If I work this out, 3 times 3 is 9, plus 4 times 4 is 16, and 5 times 5, or I should say be saying 5 squared is 25. Well, look, if I add them together, it's true. So that is Pythagorean triple. Triangle can be classified as, based on this stuff, so this is how we can classify our triangles. A right-angled triangle is equal. But if we have an acute triangle, c squared, that length of c squared will be less than the sum of a squared plus b squared. And similarly, if we have an obtuse triangle, then c squared is going to end up being greater than a squared plus b squared. So the first thing we're going to do is see if we've got Pythagorean triples here. So we'll do it two ways actually. A squared plus b squared equals c squared. I could write that c squared equals a squared plus b squared, because on the left-hand side and the right-hand side, they should equal each other. This is what an equation is. So I have to say that c is going to be 10. Why? Because c has to be the longest side. So in place of c, I'm going to put a 10, and I'm not going to forget to square it. Now I've got a choice. I can call that NA and that B. As long as they're both shorter than the longest side, let's do 6 squared plus 8 squared. And I think you can probably tell me that if I did 8 squared plus 6 squared, I'd still end up with the same answer. 6 times 6 is 36, or to say 6 squared. 8 times 8, or 8 squared, is 64. And 10 times 10, or 10 squared, is 100. And I think you can see that if I add these up together, I'm going to get 100 on both sides. So therefore, yes, these are Pythagorean triples. Let's call it a triad. Kick. Now we have the same thing with 4, 5, and 9. Think about it. Which one is going to be our hypotenuse, or C? It has to be the biggest one. And this could be A, and that could be B, or the other way around. Who cares? So this time let's write it another way. C squared equals A squared plus B squared. It's exactly the same as the previous, but I just put C squared on the left. I was in a funny mood. So I make sure I put the largest number here, squared, and that'll be equal to whichever I've chosen to be A of the shorter sides, squared, plus whatever I've chosen to be B of the shorter sides, squared. And remember, this is only going to be equal if we have right-angled triangles. On the left side, 9 times 9, or 9 squared, is 81. Okay, so let's see if the other side equals that. So 4 times 4 is 16. 5 times 5 is 25. I think you can see what's happening here. 16 plus 25 is only going to give us 41, and 41 is not equal to 81. So therefore, it is not. These three numbers will not be a Pythagorean triple or triad. Now we said before, look, a right-angled triangle will have c squared is equal to the sum of a squared, the two shorter sides squared. If we have an acute triangle, let's go back and look at our notes. We have an acute triangle. C squared is going to be less than. When we come out with this, and here's our less than symbol, a squared plus b squared. We have an obtuse triangle, then it's going to be the opposite. C squared will end up being greater than a squared, the sum of a squared and b squared. So let's find the first one. For a, who's going to be our c? We've got 4 and 7 and 9. So that's got to be c because it's the longest side. End of story. Sorry, anybody else. What do we want? 4, do you want to be a? Sure. 7, you want to be b? Why not? So we've got c squared. We're working with, does it equal a squared plus b squared? C squared is 9 squared. A, we chose 4. 7. 9 squared is 81. 4 squared is 16. 7 squared is 49, isn't it? Check with the calculator. 49. 49 plus 16 is 65. So 81 and 65. 81 is greater than 65. So this is, and I think you might even be able to see here that that's bigger than 90 degrees. So this is an obtuse triangle, which is not the correct pronunciation, but we're having fun. And now this one, similarly, we're going to do c squared maybe equal. This is where, so here's our longest side, so that's got to be c. So it's this angle we're looking at. Doesn't look like it's a right angle. I don't know, does it look acute? If it is, then we're going to find that c squared is going to be less than, so 8 squared will be less than, let's see, I don't know, I'll choose 6. One of the shorter sides squared plus the other of the shorter side squared. So 8 times 8 is 64. 6 times 6 is 36. 7 times 7 is 49. 49 plus 36 is 85. So in this case, lo and behold, c squared is less than a squared plus b squared. So that means, therefore, we have an acute triangle. Look at us.